So far, we've covered, this last week, part of last week, and most of all this week, we've covered multiplication and division. That's the only thing we've really done so far, yes? Well, today and tomorrow, we're going to be covering addition and subtraction. Now, addition and subtraction, why is it going to take 2 days? Because when we look at this here, I know I can add two fractions if what?
They have the same denominator.
The denominator. If the denominators are the same, the bottom of the fraction is the same, I can add the numerators. Now, the denominator does not change because it's going to stay the same. And we add the numerator, so 7 plus 3 is?
5/2x.
Because 10/4x do have a common factor, and if there is a common factor, we need to reduce it. 10/4 is the same as 5/2. They have a common factor of 2, so we can reduce it. And that is it. Now, we wouldn't put any restrictions for this here, because the only restriction is when x is, but it's still listed, so we don't have to list the restrictions for this here. Okay, let's look at the next one. Well, the denominators are the same, so we would subtract the numerators. Now, we do need to make sure there's no common factors on top and bottom. So when we look at 2x minus 5, well, there's no common factors between them. There's no way to factor it. And there's nothing in common on top and bottom, so we are done. Questions on this here? Oh, wrong direction. Okay, so we have 8/12x minus 5/12x. What can we do first? We can just subtract. Right, because since the denominators are the same, we can subtract, so we can do 8 minus 5, which would give us 3. 3/12 gives us 1/4x. Why would I not simplify the 8/12x?
Well, because you gotta subtract it first.
Right, because what would happen to the 12x? It would become what? 6x. The denominators would not be the same. Because then we'd have to make them be the same by making it back to 12. Well, it'd just be a waste of a step. How about the next one? 1/x squared, because we can, the denominator is the same, so we can add them. We get 3/3x squared. 3/3 reduces, and we have 1/x squared. That's it. Questions on this here? Let's skip number 3. Let's look at number 4. So I know that the denominators are the same, so I can add the numerator. So we get 2x squared plus 2 over x squared plus 1. So we just added the numerators because the denominators are the same. Is there anything we can do after that?
Could we make it 4x squared? Or
no.
Just 2/1? Not the limit to 2/1.
Well, there's a common factor of 2 on top, yes? So I can factor it out, and what would I be left with? X squared plus 1, and on the bottom I have x squared plus 1. So we can factor something out of the numerator. Move that up a little bit. Well, wait a minute. Do we have something in common on top and bottom? X squared plus 1, so those will simplify out, leaving me with 2. But this time x squared plus 1 did simplify out, yes? So we might have some restrictions. So what value of x is going to make x squared plus 1 equal 0? That might be a little bit hard to see, yes? So let's go on and solve it. So we would subtract 1 from both sides, because those would cancel, leaving me with x squared is equal to -1. And then we would do what? Square root both sides is equal to plus or minus I. So is there a value of x that would make this 0? Well, no, not a real value, because we have I. So that means we don't have any restrictions, because there's no real values of x that will make this equal 0. So the answer is 2. That's it. Questions on this here? So we like addition and subtraction, yes? At least for now.
Not now.
Unlike denominators. Because it's not always going to work out that the denominators are going to be the same. So we need to make the denominators be the same. Now, the way that we make the denominators be the same is using something called LCM. Least common multiple. And greatest common denominator and least common multiple are probably two of the most flipped things. Get them backwards. Because greatest common denominator, we're looking for the smallest or kind of the biggest number that will go into all of them. Right? So you're looking, when you get all the factors, you're looking for the smallest number that will go into everything. Least common multiple, we're looking for the biggest number that I can make everything be. And I always, because I remember this even in middle school or whenever I went over this first time, like, this seems backwards. We're doing least, but we're finding the biggest. What? Let's go on and look at one, because I feel like when we start looking at this here, trying to make them be the same, least common multiple adds it's helpful, but not always. Okay, back up. All right, we're going to find the sum. Now, as we can tell already, and we can look at this here, the denominators are not the same, correct? 9x squared and 3x squared plus 3x are not the same. Okay. Well, we can't factor x, and we can't factor 7. 9x squared, I think that's as simplified as it gets. Yes, it's a term. We can't do anything with it. But can we factor the 3x squared plus 3x? Well, yes, it has a greatest common factor of an x. So what does that leave us with inside the parentheses? Okay. Now this here, what we're about to do is probably going to make least common multiple seem not as necessary anymore. Now what we're wanting to do is we want the denominators to be the same, yes? Okay. That means I'm going to have to multiply each of these denominators by something so that they can be the same, yes? Okay, we'll start on the one on the left, the 9x squared. So this is what we have, yes? Well, we need the one on the right, this one here, 9x squared to be the same, yes? Well, I have 3x. Well, what do I need to do to 3x to make it be the same as 9x squared? Right, because 3x times 3x would give me 9x squared, yes? So that's the same. So now, with this multiplication, does this rational expression, this fraction, have everything that this one has? Well, yeah, with that 3x, they would be the same, wouldn't they? Because this fraction now has everything that this one does, yes? Okay. Now we're going to go the other direction. What does this fraction have that this one doesn't? On bottom. We're looking purely at the x plus 1, yes? Okay. I'll multiply it by x plus 1. Because that's really what we're looking at. Least common multiple, we're wanting them to be the same, yes? So we could go through and factor it and look and see how do I make them be the same. Or, well, The one on the left is missing an x plus 1. Let's multiply it by it. The one on the right's missing, oh, we need 3x for it to be the same as 9x squared. We'll multiply it by it. Is that a little bit easier than least common multiple? I mean, with parentheses, it does. With numbers, if we're purely looking at two numbers, least common multiple is a little bit more helpful. But I can't multiply just the denominator. I also have to multiply the numerator by it. Really, what are we multiplying both of these fractions by? What's x plus 1 divided by x plus 1? 1. We're just multiplying both of these fractions by a fancy version of 1, yes? That's why we can do this. Okay, any questions on this here so far? So this is kind of making sense a little bit, liking this a little bit better than just doing least common multiple. Because if we're looking at this from a pure mathematical standpoint, we would have figured out the least common multiple onto the side, and then seen, okay, what do I need to do to 9x squared to get to that least common multiple? What do I need to do to 3x times x plus 1 to get to that least common multiple? I like this way better. Now, the denominators, we're not going to multiply out, because it's just going to be 9x squared times x plus 1. 3x times 3x will give us 9x squared times x plus 1. And when I say multiply out, I'm not multiplying through, we're not distributing through that x plus 1. If we have multiple sets of parentheses, we're not going to multiply them out. Because if you notice on the first ones we did, we ended up with how many fractions at the end? Well, 1, right? And if anything's going to cancel out on top and bottom like we did with multiplication, I have to have the denominator factored for that to work, because then we can cancel out. So we don't ever multiply through the denominators. Well, the numerators are going to end up being what? Added or subtracted, yes? Okay, we've actually got to multiply the top. So that means I have to multiply x plus 1 by 7. We have to do 7 times x, which would be 7x. We have to do 7 times 1, which would be plus 7. We actually have to do this. We have to multiply through. Now, on the other side, we're going to have 3x times x, which would be? Now are the denominators the same? Yes, so that means we can add the numerators. And according to number theory, 3x squared would go first. Plus 7x plus 7 over 9x squared times x plus 1. I'll tell you right now, this is as simplified as it gets, because 3x squared plus 7x plus 7 is not going to simplify further than that. That's as simplified as it gets. So we could have, especially on the homework, if you want to check, the b squared minus 4ac is the easiest way to kind of see, is it factorable? Because if the number that comes out of this is a whole number, no fractions, or well, you won't get fractions. As long as it's a whole number, it's good, because if it comes out imaginary, it doesn't work. If it comes out as an irrational number, a non-repeating, non-terminating decimal, it doesn't work. Questions on this here? No, I'm just going to mark. Next page. You can do it. There we go. And this here is why it's going to take 2 days, because we're going to go through more examples of this again tomorrow. Because doing these here is sometimes hard to see. Okay. So I can't factor 8 or, let's see here. What can we do first? Right, there's a common factor of 4 and 8 and 12, yes? So we can factor that out, because if I factor 4 out of 8, I'm left with 2. If I factor 4 out of 12, I'm left with, and I have x squared. We can't do anything with x on top, but in the denominator, what can we do? I can factor out an x, yes? Which leaves me with x plus 1. What can we do next? Yes.
Why didn't we write a 4 out to the side of the 2 and 3, but we did for the x?
And the last one?
Oh, this one right here. So we took 4 out of 8 and 4 out of 12.
Mm-hmm.
We didn't put a 4 beside it, but we did for an x.
Yeah, because since here it's on top and bottom, these would reduce to 1.
Okay.
Now, on the other one, the other set of fractions, here I got this from the denominator. I pulled an x out of the denominator.
Okay.
Now, it just works out there as an x on top and bottom, yes? So can we reduce that? Will it be helpful? It's here, I'll go on and erase this here, because I think you all have it written out, yes? So let's see what happens. So I have this here, yes? Okay, the denominators are obviously not the same, yes? So over here, I'm going to have to multiply on both sides. I'm going to have to multiply it by something. Well, here I just have x plus 1, yes? So what does this fraction's denominator have that this one doesn't? 3x squared. Okay. So we're multiplied on top and bottom, yes? Simplified it out. Now say I didn't. Say I didn't simplify it. We have x and x. Well, I don't need 3x squared anymore. What do I need? It already has 1x, so I just multiply it by and 3x. So here, did it make a big difference? Well, no. So it sometimes is helpful, sometimes is not. Because simplifying it, it didn't change anything. Because even without it, it just means that this is squared. So there's nothing wrong with that. It would almost be the same thing here as if this was a 2. Not a 2. Let me rewrite that. Let's say 4. 4 is going to make more sense. Well, if I have a 4 here, oh, wait a minute. I've got to multiply this by 4 over 4. 4 times 3 is 12. Y'all see that there? So sometimes reducing on top and bottom helps. Sometimes we end up back where we were. So don't be hesitant to reduce something on top and bottom just because we might have to put it back. It can sometimes help. It can sometimes make these a little bit easier to work with. Okay, any other questions on this here? Now, what is the other fraction, that one on the right, missing? X plus 1. Now again, on the denominators, we aren't going to multiply through, so we're just going to have 3x squared times x plus 1. And over here, we're going to have 3x squared times x plus 1. Now here in the numerator, we're going to have to distribute the 2. So 2 times x would give us 2x. 2 times 1 would be plus 2. 3x squared times 1 will be, well, 3x squared. Any questions on how we got to this here? Okay. We can add these two together and rewrite it according to number theory. And this here is our final answer. Because 3x squared plus 2x plus 2, that's not going to simplify. There's no way to factor it. So this here is as simplified as it gets. Questions on this here? All right. Find the difference. We're going to find the difference of these two here. Okay. Now the numerator x plus 2 is not going to change. The numerator negative 2x minus 1, that's not going to change. Those are going to be the same. Because there's nothing we can factor out, there's nothing we can simplify, and even if we could, we leave them alone. Because again, if we're adding or subtracting, well, if things are factored in sets of parentheses, the only way I can add them to something else or subtract them from something else is to multiply them back out. So we don't normally factor the numerators until the very end. Now the denominators, because they're different, 2x minus 2, we can do what? We can factor out a 2, which would leave us with an x minus 1. Because the 3 is positive, the signs are the same, and they match the sign in the middle of the term, so they're both going to be negative. Factors of x squared would be x and x, and the only factors of 3 are what? 3 and 1, 1 and 3. Okay. Okay. So what does this denominator have that this one doesn't? And that's it. Because it has, the only other thing that the one on the left has, this denominator has, is x minus 1. It already has it, so we don't need it. The only thing it has that this one doesn't is the 2. Now if we go the other direction, this one here has x minus 1 and x minus 3, so this one here is missing an x minus 3. So I need to multiply top and bottom by x minus 3. Questions on this here? Well, if we look at this here, x minus 3 times x plus 2, that is going to give us a quadratic. Yes? This here, because if we added x minus 1 in there again, multiplied both of them by x minus 1, well, wait a minute, x minus 3, x plus 2, and x minus 1, that's not a quadratic anymore, that's a cubic. That's going to make it harder to work with. And that extra x minus 1, any of these extra sets of parentheses are going to come out in the end. Because we have to factor them back out because they weren't needed. Okay. So the denominator is going to be 2x times x minus 1 times x minus 3. Now the way that you order these is not going to matter. The main key thing I would say is put 2x in front. Don't put 2x between the two sets of parentheses. That's just not something you do. Okay? It's like having a basketball jersey numbered 99. It doesn't work. Either that or that's a really weird ref. Okay, now what we need to do is we need to multiply the numerators out. So for the first one over here, we can go on distribute. X times x is x squared. X times positive 2 is going to be plus 2x. Negative 3 times x would be negative 3x. And negative 3 times positive 2 would be negative 6. Now over here, we're going to multiply both of these by 2, which is a little bit easier. Negative 2x times 2 would be negative 4x. And negative 1 times 2 would be negative 2. Any questions on any of this here so far? Okay. Now we can combine some like terms to make this a little bit easier to work with. 2x minus 3x would be negative x minus 6. Okay. So we have everything simplified. Now we can go on and subtract. Yes? Y'all need to be careful with this here, especially with subtraction. We need to be careful with the signs, because it is going to be on one fraction, and the denominator will be 2x times x minus 1 times x minus 3. There's nothing wrong with that there. The x squared minus x minus 6 is fine. We'll go on and put them in parentheses. Minus. The second one that we're subtracting, you need to make sure you pay close attention to the signs, because it's going to make a difference. Because we're subtracting both of these here. Essentially, we end up multiplying both of them by -1. Which for addition didn't do anything. Addition doesn't change the signs. X squared minus x minus 6, there's nothing going to change here. But we have to apply this negative to both the -4x and -2. Well, negative 4x, if we subtract a -4x, the negative and negative would make a positive. So that really this is plus 4x. The negative and -2 is going to make it plus 2. So if we're not paying close attention, it is very easy to get one of these signs wrong. It is very easy to get one of these signs wrong when we're doing subtraction. Questions on this here? Okay. Now we can go on and actually subtract and combine like terms. And when we do that here, well, x squared is by itself. Negative x plus 4x is going to be plus 3x. Negative 6 plus 2 would be -4. Any questions on how we got to this here? Any questions on any of this here so far? Well, it works out that the numerator will factor. X squared plus 3x minus 4 will factor. This here will factor. Well, since the 4 is negative, the signs are opposite. And what are the factors of x squared? And x. Now, the factors of 4 are 1 and 4 or 2 and 2. Which one do we want to try first? Which one do you think it is? 1 and 4. Which one's going to be positive? Which one's negative?
One's positive.
And one's going to be
Oh, yeah.
negative. And it does work out, because we'll have x times -1 would be -x. And 4 times x would be plus 4x, which gives us a positive 3x, which we wanted. But it does something more than that. What does it do? Top and bottom have what? Common factor of x minus 1. So it will simplify, it will reduce, which leaves us with x plus 4 on top and 2x times x minus 3 on bottom. And for the first time today, we will have a restriction. And what's our restriction going to be? A 1. Because we lost this here, this x minus 1. And when you set it equal to 0 and solve, we'll add 1 to both sides and see that it's 1. So x cannot be 1. And this is where we're going to stop here for today. We'll pick this up tomorrow and get this started here. So when we look at this here, we're really continuing on with what we did yesterday with our subtractions, or adding and subtracting. And again, the numerators are not going to change. We're not going to factor, we're not going to do anything to them here because, well, if we factored them, we would have to undo it to be able to add the 2 or subtract the 2 here together. But we do need to factor the denominator so we can see what we need to make them be, how to get them to be the same. Now we look at x squared minus 3x plus 2. we will have two sets of parentheses. Because the 2 is positive, the signs will be the same, and they're both going to be negative because the middle term is negative. Now the factors of x squared are going to be what? X and x. The factors of 2 would be 1 and 2. So we get x minus 1 times x plus 2. X minus 2. X minus 1 and x minus 2 would be the factors for this here, and that is factored completely. Now we need to look at the denominator of the other fraction, so we have 2x minus 4. We can factor out a 2, which would leave us with x minus 2. So we have this here. And because since the reason we're factoring the denominators is so that we can see what we need to multiply each fraction by to get them to be the same. Because if I can get them to be the exact same, then we can add or subtract them from each other. So if we look at the one on the left, what does it have that the one on the right doesn't? X minus 1. Because the one on the left it has x minus 1 and x minus 2. Those are the two things it has. Well, the one on the right has an x minus 2. It doesn't have the x minus 1. So we're going to multiply it by x minus 1 so that they can be the same. Now we're going to go the other direction. What does the one on the right have that the one on the left doesn't? Well, 2. So we're going to multiply it by 2 over 2. Try to make them be the same. And I think this is a little bit easier than writing x minus 1 times x minus 2 and 2 times x minus 2 on the side and using the least common multiple to figure out what it is. It's a little bit easier if we can just look at it and see this one needs this and this one needs that. Okay. Now that we have the denominators the exact same, so we multiply. So we have 2 times x minus 1 times x minus 2. Minus 2 times x minus 1 times x minus 2. Because the denominators are going to be the exact same. Now the numerators we do have to multiply through. So we're going to have to do 2 times 5x and 2 times negative 1. Well, 2 times 5x is 10x. 2 times negative 1 is negative 2. Scroll up a little bit. Now here we are going to have to distribute through. So we're going to do negative 2 times x, which will give us negative 2x squared. We'll have to do negative 2 times negative 1, which would be plus 2x. And negative 1 times x would give us negative x. And then negative 1 times negative 1 would give us plus 1. So when we multiply this through, we get negative 2x squared plus 2x minus x plus 1. Any questions on how we got to this point here? Or any questions on any of this here so far? We good with this here? Okay. Well, now we can combine some like terms. Over here, because 2x minus x will just give us plus x. And everything else stays the same. So the 2x minus x, we can combine those because they are like terms, so they will go together. Any other questions on any of this here? Okay. Now, at this point here, there's two different routes we can go, and this is really going to depend on your own personal choice. Now, if you feel confident about this, in that I can see, okay, I'm going to change everything up here. The signs for that second part are going to change because we're subtracting it. The negative is going to change the sign of everything on top. So a negative and the negative 2x would become positive. So it'd be plus 2x squared. A negative and a positive make it minus x and then minus 1. So if you feel comfortable with doing that and being able to flip those signs, you can do that there. Now, if you're not as comfortable with flipping it and making sure that that went the way it's supposed to, you don't have to do it that way. Because what we can do is do negative and have both of these in parentheses, and then drop the parentheses and apply that negative. So if you don't feel as comfortable just switching from one step to the next, write it with parentheses and then change it. If we can write it this way, and then I can drop those parentheses and change the signs of the second. Okay. We're almost done. The last thing we need to do is combine like terms and factor, if possible. So any questions on this here? Very similar to what we did yesterday. So we have 2x squared. 10x minus x is going to be plus 9x. And negative 2 minus 1 is negative 3. Over 2 times x minus 1 times x minus 2. And that's it here. And there's no real way to factor this, so using 2 and 3 to get to 9, it just won't work. So this is as far as we can take this here. Now, there are no restrictions for this here because nothing's simplified out of the numerator or denominator. So all of our restrictions that exist are still listed. So we're not really adding anything to this. Questions on this here? Are we good with this here? Yes? Yeah, no. I mean, we could do this here, but really, what we would be doing is I'd multiply this by 4x over 4x. This one by 7 over 7. Is to get 28x over 4x and 21, which would give us negative 4x plus 21 over 28x. And that'd be it. There's not too much to that one. We'll look at this one here, which I believe is the last problem. No? Yes. There's one more? Okay. We'll have this one here, and we'll see how y'all feel at this point. So when we look at these two here, well, again, we're not doing anything to the numerators. We're not going to factor. We're just going to leave them alone. Now we can look at the denominators. Well, 3x squared is one term. There's no way to simplify it down. That wouldn't be helpful. That would be helpful. So we have that there. So what can we do to the other one? Yes, we can factor out a 3. And if I factor 3 out, 3 factored out of 9x squared would leave me with 3x squared. Minus, if I factor 3 out of 12, I'm left with 4. Okay? And we factor that again. So it's 4 perfect square. And they're being subtracted, yes? So it's a difference of perfect squares, correct? It's 3 a perfect square. No, so that throws that all off. Because if 3 was a perfect square, then it would work. If this number with x squared was a perfect square, well, 9x squared is a perfect square, yes? Is 12 a perfect square? Well, no, so this is as far as it factors. So the most we could do is factor out a 3. Okay. Now we need to make the denominators be the same. Okay, so let's do this here. So what does the one on the left have that the one on the right doesn't? And there is one thing. So here we have 3x squared here. So we do have a 3, yes? And this one has the 3x squared minus 4. So what does this have? It doesn't have an x squared. Now the one on the right does have an x squared, but it's what? 3x squared minus 4. All of those are stuck together. This is a term. So this x squared is actually different from this one here. They're different terms completely. And the main reason that is because the one on the right is being multiplied by 3 and then subtracted by 4. The other one is just by itself. So those are going to be considered two different things. Now if we go the other direction, what does the one on the right have that the one on the left doesn't? Yes. It has that whole term. So the denominators don't change because they're going to be the same, because, well, we can't do anything if they aren't. Now we can multiply the numerators. Well, 3x squared minus 4 times 1 as well. 3x squared minus 4. Over here we have x times x squared, which is what? X cubed. Well, now we can add, yes? And according to number theory, we would have x cubed plus 3x squared minus 4. And I'm going to go on and tell you this is as simplified as it gets. Because for us to really factor that numerator, we need one more term. Because I need an x term, a term with x to the first power, really to possibly be able to factor this. But this here is as simplified as it gets. Because the only other way we can rewrite it is if I broke it up into individual terms, which really isn't making it simpler. It's making it into 3 fractions instead of 1, which doesn't help us as much. And that's it. That's all we have to do for this here. Questions on this here? All right. Draw a blue line.